Alright, 4.7 optimization. So we're basically going to do some word problems that involve finding relative mins and maxes, which is a form of maximizing or minimizing whatever the word problem involves. So example 1, finding maximum volume. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches as shown in the figure. What dimensions will produce a box with maximum volume? Alright, so first of all, looking at this box, let's try to figure out an equation that will represent the surface area. We know that the surface area is 108. Okay? And surface area is all the sides of the figure. The area, adding up the area of all the sides of the figure. So if we look at the base here, the area of that base would be x squared plus, now let's look at the area of the sides. So this side here is x times h, and there's actually 4 of those sides identical. This side here would also be x times h, same with this side, and same with that side. So this is going to be 4xh. This would be the formula that represents the surface area of this figure. Also, what we want to maximize is the volume of this figure. To figure out the volume of this figure, you multiply the length times the width times the height. So the volume would equal x times x, which is x squared, times h. This is what we want to maximize. Okay? So we want to take the derivative of this function. Before we take the derivative of this function, let's see if we can solve for h in terms of x. And I think we can do that by looking at the surface area formula. So let's solve for h. So first of all, I can subtract x squared from both sides, leaving me with 108 minus x squared equals 4xh. Then I can divide both sides by 4x, and that will equal h. Now I can take h, substitute it in here. So now this is going to become v of x equals x squared times 108 minus x squared all over 4x. Now this is a function in terms of x, so v of x. Now let's simplify this a little bit. Notice that the x's here will reduce. So I'm going to have v of x equals x times 108 minus x squared all over 4x, or I'm sorry, over 4. Then I can multiply the x through and get 108 x minus x cubed all over 4. And now let's take a look at this function here. So again, this function, this is what we're trying to maximize. So the first thing I'm going to do, I'm going to find the critical numbers, because the relative min or max is going to happen at the critical numbers. So I'm going to take the derivative of this function, which you can think of this as being 1/4. Might be easier just to do it. So let's go ahead and divide 4 by each of these. So 4 goes into 108. Let's see, 2 times 4 is 8. 10 minus 8 is 2. 4 goes into 28 7 times. So this is going to be 27x minus 1/4 x cubed. Probably going to be easier to take the derivative of that. So this would be 27 minus 3/4 x squared. And then to find the critical numbers, we need to figure out the x values where v prime of x is equal to 0, and the x values where the derivative of f of x does not exist. Since we don't have a variable in the denominator, this one doesn't come into play. This does come into play. Let's take 27 minus 3/4 x squared, set that equal to 0, and then this would be 3/4 x squared equals 27. Then let's multiply by 4/3. This would be x squared equals 36. Square root both sides, x would equal plus or minus 6. Now, since x represents the length of a side here, negative doesn't make sense, so we're only going to evaluate x equals 6. Now we need to figure out whether this is a maximum or not. This 6 inches. So to do that, we are going to take the derivative of the first derivative and get negative 3/2 x to the first power. I'm just taking the derivative of this. Derivative of 27 is 0. And the derivative of negative 3/4 x squared would be negative 3/2 x. Now, if we think about the domain of the volume of this box is going to be 0 to infinity. Okay. Well, I guess this represents the length of the side x. Okay, where x is 6. So to figure out if this is a maximum or not, let's use the second derivative test and do v double prime of 6 and see if that's greater than or equal to 0. Well, if I plugged in negative 6 into this, or I'm sorry, plug 6 into this, this is still going to be negative, so this is going to be less than 0, which means this is going to be concave down, which means we have a relative max at x equals 6. So now, to answer the question, what are the dimensions that will produce a box with maximum volume? Okay, so x, so it would be 6 inches by 6 inches by h. Alright, so I have to go back and find h again. H was 108 equals x squared plus 4xh. Subtract x squared from both sides, you get 108 minus x squared equals 4xh. Divide both sides by 4x. And now plug in 6 to figure out h. So this would be 108 minus 36 all over 4. You could divide all those by 2. This would be 54 minus 18 over 12. Divide all those by 2. This would be 27 minus 9 all over 6. You could divide all those by 3. This would be 9 minus 3 over 2. So this is going to be 6 over 2, which is 3. 3 inches. This would be the dimensions.